Hello, my name is Joe,
And my name is Mackenzie Hall.
and this project is training a neural network to learn the Uncanny Valley. What is the Uncanny Valley? First identified by Masahiro Mori in 1970. It is the more human something looks, the more empathetic we feel towards it until a certain point is reached at which those feelings will turn to revulsion and possibly disgust, until eventually they circle back to being more empathetic again, essentially making an emotional valley in terms of shape. Mori was not the first to discern this, but he was the first to identify it and conceptualize it in terms of words. The main reason for having this project is we want to see if a neural network can learn something so subjective as human emotion is in response to images of near perfect items. As you can see, here is our convolutional neural network architecture. We start with an input layer, then we go to our 8 hidden layers until our output. Our hidden layers are our convolution and ReLU activation layer, going into a pool, and then another repeat of that, into a flattened layer, and then we go to our fully connected and ReLU activation layer twice before going to fully connected and reaching our output.
For our methods, we compiled our own dataset of over 250 images, trying to evenly divide the distribution between uncanny and not uncanny images. About 20% was used for testing, or around 40 images total. The purpose of the network is to determine a binary uncanny or not based on the image read, outputted as 1 or 0 respectively. To process the dataset, we had to use the pillow thumbnail function to resize the images while still retaining their aspect ratio. The images were then fit to the desired sizing with the addition of padding, the code as shown in the picture with our defined rescale class and expand to square function. The cross entropy loss function was used to calculate the loss. The final neural network and parameters used were determined by comparing batch size, image size, number of epochs, and the usage of the sigmoid versus ReLU activation function. Finalized batch size was determined to be 5, image size 200 by 200, number of epochs was 20, and the ReLU activation was used. The network ended up predicting specific images wrong consistently, such as the image depicted here. We think this error may be due to lighting or other inconsistencies between images. Overall, we did find an accuracy of up to 99% in training and up to 97% in validation. An example of its respective network output is also displayed, along with the accuracy of the run. Comparison for the parameter changes is featured on the next slide. We tested each parameter with 3 values across a considerable range, with the smallest and largest value loss plots displayed here. We found with a smaller batch size, loss decreased faster and reached near 0 by the end of the run. A greater image size decreased performance but also decreased loss. For our convenience, we still settled on a 200 by 200 image size. The number of epochs became redundant after about 50, in which loss remained a near 0 beyond that. In terms of architecture changes, the ReLU activation increased both the performance time of the network as well as decreased loss overall with both training and validation sets.
In analyzing results, we noticed we had an accuracy plateau of around 97%, and that more training did not necessarily lead us to getting better results from our model. Issues we noticed that were quite frequent was that our quality and quantity of data both lacked sufficiency. Quality-wise, the image sets we used to construct our model varied heavily in what they contained. Some images were very realistic and only lacked in 1 or 2 areas for uncanny. Others may or have fallen into a gray area where they were not easily identifiable characteristics-wise. Quantity-wise, our data set was largely restricted by the number of uncanny images, more so than the canny due to the subjective nature of most image locales having similar if not the same images. Testing-wise, our images missed in some tests in our testing data, tended to repeat multiple instances even when retrained. Improvement-wise, we need to look at refining our training data set and analyzing our validation set for inconsistencies with the training set. Thank you.